Welcome. Today we're going to discuss the fundamentals of providing good estimates in the software development process. This is such an important task, but there's some fundamentals that if you get those fundamentals right and you understand those, then your estimates are a lot more accurate and you kind of minimize that uncertainty. So let's get into it. So this is the question that you're going to be asked, or maybe one of these derivatives. When will you be done? When is feature X going to be done? And so it's very important that you feel comfortable answering these questions. And also, you need to be able to build trust with your client or whoever's paying your bills that you can answer this, accurately and correctly. Typically, as software engineers, we have a backlog of features, and these features are in the form of words, right? So we get requirements, and we have to take those requirements, those words, and we have to convert those to kind of working or production code. And so that process of converting words to production code obviously takes time. And that's what we're being asked for, is we're being asked, how much time is it going to take to convert those words to the production code? And so there are some fundamentals, and we're going to get to those fundamentals, but let's talk about why this is important first. So number one is typically the person asking is the person that's writing your check, either directly or indirectly. Maybe you're a consultant and your client's asking you, how long is this going to take? Maybe you work for a company and you're doing software development for that company, and your manager and their boss, their director and the VP and the CTO, they all want to know, how long is this going to take? So it's important that as software developers that we understand these fundamentals so that we can answer this correctly. And I underline the word correctly here because it's not just being able to answer accurately, giving them a number, hey, this is going to take 5 days. But you also need to talk about the uncertainty, which we're going to dive into a lot during this discussion, is what's the uncertainty level? How can we minimize uncertainty? And so by knowing some fundamentals, we can reduce the uncertainty in our estimate. And that way, when we say 5 days or 6 months, we can kind of confidently say that's 6 months with this much uncertainty. And those two things need to be relayed together. So here's a few things why it's important to be able to answer correctly. First of all, it establishes trust, with the software development team, to kind of the leadership team, all the way up the stack. This is really important to be able to have that trust so that when the CTO hears your answer of 6 months, they understand what that means. The next positive benefit is it provides visibility. Imagine, these features 1 through 3 over here are going to be unveiled at a trade show, and that trade show is scheduled for 6 months out. And so as the CTO, I have a presentation planned. I'm going to get up in front of this audience and I'm going to unveil these new features at that trade show. I need to have some visibility into when those features are going to be completed. And that allows the organization to take some risk management options if they need to. So for example, if the software development team says that this is going to take 5 months to do, I have a 1 month buffer. I feel pretty comfortable with that. But if this is all going to come out the week of the trade show, then I need to be able to mitigate some of that risk. So maybe what I'm going to ask is the development team not so focus on feature 3 because it's less important, but really make sure feature 1 and 2 are solid. And as a leader of a team of software engineers, it's important that I be able to predict the cadence of when software is coming. And a lot of times our cadence is predicted by kind of our process. Maybe it's a Scrum process where every 2 weeks we have a sprint that ends, and that's the cadence where kind of working software is going to be introduced into kind of the production pipeline. Or maybe it's like a Kanban board where you're plucking the top task and you're just working it through your lanes and then it comes out. But regardless, I need to be able to predict that cadence. How fast can words get turned into production code? And then obviously when you have larger projects that are going to span 6 months or a year or something like that, it's important that you know these numbers, and that way we can have better project planning. So before we dive into the fundamentals, let's spend a brief moment and talk about that word uncertainty, what that means. There are degrees of uncertainty. Depending on the topic that you're talking about, maybe you can be 100% certain, or maybe you're 100% uncertain. You don't know. Fortunately, software engineering, we take these requirements and we turn them into working code. It tends to be more of a concrete process, something that it's a little bit easier to, provide an estimate for that's reasonable. And that's why we're going to talk about uncertainty is how much uncertainty is there and how to reduce or mitigate uncertainty. And so if we take an example on this scale of uncertainty where the left side is low and the right side is high, let's just talk about an example. And in the beginning, I'm going to talk about non-software development examples because on our teams, on our development teams, we're going to have obviously software developers who will understand the software development process, but we're also going to have people who maybe don't. Or sometimes in our meetings, we have kind of product owners who maybe haven't written code, or we have stakeholders or sponsors, and everybody needs to have the same language. So it's important that they can relate to what we're talking about, and so this is an easy way for them to relate to things. So let's talk about an estimation where you're talking about distance. This first example is very low uncertainty, right? If I ask you how many inches in a foot, almost everybody is going to be able to say 12 inches. And for most of us, the uncertainty in our answer is 0. I mean, we know that. That's our domain knowledge, all right? So with domain knowledge, we can reduce uncertainty. But if I ask you a different question, how many inches between the Earth and the Moon? That question has a bit of uncertainty. And imagine that you're asked in an environment where maybe it's an interview process, and so you don't have access to technology or anything, and you just have to take a guess. And so if you had to guess this, based upon your previous knowledge, maybe you kind of remember how close it is. Maybe between the Earth and the Moon, it's around 200,000 miles, and then you could take that guess and convert it from miles to feet, but you may not remember that conversion process, so how many feet in a mile, and so on. So down the line, we have uncertainty that we've introduced in our answer. But luckily for our software development tasks, a lot of the time we either have domain knowledge on our team about certain topics, or we can borrow domain knowledge. And in this case, I will probably borrow domain knowledge from Google, and I would Google this and find out how many miles there are between the Earth and the Moon. And Google will reply with an answer. It's an average distance because it's an elliptical orbit, but it's going to give you the average distance. If you don't know the conversion between miles and feet, you can Google that, but eventually you can end up with a number. And by borrowing domain knowledge, I've reduced the risk from the initial question down to kind of an answer where I can confidently say, this is how many inches on average are between the Earth and the Moon. And so this is an example of where measurements or domain knowledge reduce the uncertainty. We're kind of building fundamentals here, and so this is one of our fundamentals of being able to reduce uncertainty is by leveraging domain knowledge. It's worthwhile to take some examples again of just what that process of providing an estimate looks like. For our examples, usually we're asked to how much time it's going to take. And so let's just revisit this formula. We introduced this probably in high school or maybe middle school for some of us, but there's a velocity definition that is change per time. So how much change happened and how much time it took for that change to happen. That's roughly, that velocity. You can get more into, derivatives and all of that, but I think that's just a little more complex. But let's leave it like this. Now, this particular formula, if I rearrange those variables, I can come out with a formula for time. So time is the change divided by the velocity. Or if I'm ever asked to compute the amount of change, if I know that the velocity and the time, I can compute that. So mostly in software engineering, we're asked for the time variable. So we're going to be using this middle equation a lot. So the process that we're going to go through is, we're going to know what the amount of change is, and we're going to know our velocity, and then we're going to be able to compute the time. Trivialize this. Let's go to an example that has 0 uncertainty. This is the kind of word problem that you might have seen in high school. An object is traveling exactly 100 miles per hour, and it's traveling a total distance of 100 miles. And your job is to estimate how long the trip will take. We can tweeze these numbers out of the story, and we can find that the total change is 100 miles. That's how far we have to go, and that the velocity is 100 miles per hour. And then we can use that middle formula and compute our time. Now, this computation, again, because there's no uncertainty expressed in these numbers, that is exactly 100 miles, and the velocity is exactly 100 miles per hour. We have an exact estimate, 1 hour, no uncertainty. Something maybe more closer to the software development process that we do is, let's take an example of a robot. A robot's performing very repeatable actions and it's building 5 parts an hour, and it can work for 24 hours in a day. And we're asked to estimate how long it's going to take that robot to build 100 parts. And so again, you can tweeze out of the story, the change in the velocity, and then you can use that middle formula to compute time. So 20 hours it's going to take. And again, 0 uncertainty here. There's no uncertainty in the behavior of this robot. It's 5 parts per hour exactly, and 100 parts exactly. That's what we need to know. And then this type of equation, maybe you're the one that owns the company and you're asking questions like, can I scale this out? Maybe I want to add another robot. How quick can I do it if I add another robot? How about if I add a fleet of robots? How quickly can we produce these products? And so in these particular trivial examples, there's 0 uncertainty. That time is exactly known. But by going through this process of computing kind of the estimation, we'll kind of get used to our formula here. Let's take one more example, a non-trivial example that has some uncertainty in it. Let's say that this is the question you have to answer: is how long would it take you to walk from Seattle, Washington to Washington, D.C.? Now that's a bigger problem. So imagine you're already kind of thinking in your head, you know that formula, time is the amount of change divided by velocity. And so you're thinking change is probably the distance. All right, so you got to get distance, and then the velocity is like how fast you're walking. And so you can kind of walk through this a little bit. But to mitigate some of that risk, that first part is, how far is this? And we can borrow domain knowledge again. So we go to Google. In this example, I think I rounded this up to 2,700 miles is the answer. And Google has even mitigated the risk in our distance because it provides us a route. It provides us turn-by-turn directions. So as long as I stay on that route, Google has given us its 2,700 miles. Now the next part is the velocity. So I might kind of do a thought process that looks like this. On day 0, I haven't done anything. I have no experience at this at all, but I'm going to take a reasonable guess at my velocity. All right, so I have 2,700 miles remaining, and to get a reasonable guess at velocity, I'm thinking that I can probably walk 3 miles per hour, and a reasonable amount of time is maybe I do 3 hours in the morning, I take a break, and I do 3 hours a night. So a total of 6 hours at 3 miles an hour, I'm going to get about 18 miles per day. That's my reasonable guess. And the reason I have to take this reasonable guess is because I have no experience at this, right? So I'm just taking a reasonable guess. That's the highest level of uncertainty that I'm probably ever going to have in this process, is because I have no experience. So this is my reasonable guess. But if I use this reasonable guess and I divide that into 2,700, I can get an estimated completion days. It's 150 days. Now, let's fast forward one day. I went out, I did my 1 day of work, right? I put my boots on, I did the walk-in, and I ended up walking 15 miles. Now, I don't have to have a reasonable guess anymore, right? I did 15 miles in 1 day. So 15 divided by 1 is my new working velocity. That's a measured number. There's a lot less uncertainty. Yeah, the uncertainty is still pretty high because I only got 1 day of experience, but I have a new number. It's 15. If I subtract the 15 miles that I covered from the 2,700, I have 2,685 remaining. So 2,685 divided by 15, I have a new estimate. That estimate is 179 days I will arrive in Washington, D.C. So again, the uncertainty in this estimate is pretty high because I don't have any experience doing this. But let's fast forward. Let's give me 100 days of experience. So at 100 days, I've gone 1,750 miles. It's about 60% of the way. So maybe over here in the map, I'm somewhere maybe in Minnesota or Wisconsin here. That's about where I'm at. All right, I've traveled over the mountains. I've kind of entered the plains, and now I'm in the Midwest here. So I've got a lot of experience. So I'm starting to understand that process that I have every day of taking care of my feet, my nutrition, properly tying my shoes so they're not too tight, not too loose. My backpack, I'm getting that situated so it doesn't hurt my shoulders all day. Starting to get some pretty good experience with this process. And if I take my 1,750 miles I've traveled divided by 100, I've got a new estimate. It's 17 and a half miles per day. And I can use that 17 and a half miles and divide it into the remaining 950, and I can tell you that in 54 days, I'm going to reach Washington, D.C. Now, because of this experience that I've gained, again, I've reduced my uncertainty. So now my uncertainty, maybe it's in the medium level. But let's fast forward another 50 days. 50 days later, I've traveled a total of 2,400 miles. This is about 90% of the way there. So maybe, I'm somewhere between Ohio and Pennsylvania over here. And so I've gotten even more experience here. So, I crossed through a lot of big cities. Originally I was kind of nervous about getting through cities. I wasn't sure, if the turn-by-turn directions were going to be good for me, but I've mitigated that risk. I have that understanding now. And so now I compute my working velocity, 2,400 divided by 150. It's 16.0. That has probably the lowest uncertainty that I've seen to date. So let's say the uncertainty is low here, and I can use my working velocity and the remaining miles to compute. I still need an additional about 18 and 3/4 days. Let's take one more example. Let's fast forward another 15 days. 165 days in, I've walked 2,680 miles. There's only 20 miles remaining. I'm just outside the city here at this point. What's my confidence level? What's my uncertainty now? It's pretty low. This is the lowest it's ever going to be. I'm only 20 miles out. I've walked 2,680 miles. The process, I know the process. I've got it down. In fact, I'm feeling very confident with this. The remaining distance, 20 miles divided by my working velocity, I'm going to get there in 1.2 days. And if you notice that there's only about 3.8 extra miles between my destination and my daily working velocity. So as most of us probably get near the end, we get pulled in, and we probably can make an extra kind of spurt and flex into that last day and probably complete this in a day. But regardless, as I've gone through this trip, I've reduced uncertainty by gaining experience and domain knowledge. In the beginning, I didn't know how to take care of my feet and all the risks that were going to be involved. But as I went along, I was able to mitigate those risks, and I learned about the process. So this is an important kind of mental example of the same things that software developers go through. We kind of go through the same thing of where we're gaining experience and gaining domain knowledge and reducing risks. So that leads us to 4 estimation uncertainty principles. There's 4 of these things. And if we think about our thought process that we've gone through, number 1 is uncertainty is reduced with domain knowledge. Domain knowledge can be either earned, I've learned that, I've read about that, I've kind of done that, or it can be borrowed. I can borrow it from technology like Google, or I can bring in a domain knowledge expert, right? And they can help me with that estimate. But sometimes you're under maybe pressure and you need an estimate right away, but you don't have the domain expert there and there's nobody to borrow the domain knowledge from, but you still have to provide that estimate. So you can still provide that estimate, but it's important that you also relay that that estimate comes with a higher degree of uncertainty. Uncertainty is also reduced by taking that work, that unit of work, and we start to whittle it down and make it smaller. My estimate on the whole trip from Seattle to Washington, that had a lot of uncertainty. But as I got closer to Washington, I just had that final 20 miles, my uncertainty was reduced. And it was reduced, because I gained the experience, but also because it was a smaller unit there. It was only 20 miles. And I was able to kind of provide an estimate a little bit more accurately on that smaller unit. And we do this all the time in software engineering, right? We have a backlog of features, and to provide an estimate for a feature, we break it down into tasks, and we break those down into subtasks if we have to, but we get it down to a smaller, unit of work, and we're able to more accurately provide the estimate on that smaller unit of work. And then we roll those things back up, and we can figure out what the estimate is for kind of at the feature level. That's the best practice in software engineering. We do that all the time. Uncertainty is also reduced as we gain experience with the process. Remember in our trip that we did from Seattle to Washington in the beginning, we didn't know what we didn't even know, right? We didn't understand that our feet were going to take a beating on this process, right? We might have thought about it, but we didn't really understand it. There's a difference between knowing and doing. After we started to do it, we really understood the impact that our feet were going to take and how we're going to have to take care of them at night. That experience of the process is the same thing in software development. We have a process to get words, a requirement to working software, and that process involves not just writing code, but there's other factors in there. For example, maybe you're a medical device company and you have some compliance requirements in here. If I have no experience with that process, I don't really know how to do the estimate. After I've gone through it a couple times, I get more experience and my estimates are more accurate and I reduce that uncertainty. Teams go through that forming, storming, norming, and performing, that maturity level. But the 2 key things that mature teams can do is they can consistently size their work, and if you measure their velocity, it's a consistent velocity. And so that's the ideal team, is you want to get to that ideal where your team is able to consistently size their work and they have a predictable cadence. And then finally, uncertainty is reduced the closer we get to completion. We saw this in our kind of thought process of walking from Seattle to Washington. As I got closer and closer, my uncertainty was reduced. And this is obviously related to kind of the experience, but I've mitigated a lot of risks. This particular principle turns up a lot when we have to provide estimates. An estimate where I'm saying, hey, we're going to be done in 1 week, versus an estimate where I'm saying, hey, we're going to be done in 6 months. This 1 week estimate has a lot less uncertainty in it compared to this estimate of, I'm going to be done in 6 months. So those 2 estimates are very different levels of uncertainty. So these are the 4 principles, and we're going to apply those now as we start to do estimations in software development. So if we look at the software development, that estimation process in software development, we start off with a backlog of features. Typically, this backlog has already been kind of prioritized by maybe product owners, but regardless, we have this list of features, and this is a prioritized list, but we're just going to look at feature 1 here. To provide an estimate of feature 1, we're going to do what we already talked about. We're going to break this down into smaller units of work. Now I have 5 tasks, but if you look, task 5 is still a little chunky, so I might still divide this up into 2 subtasks. But now I'm at a level where the team can take those estimates. And again, task one, maybe it's a front end task and it's about developing some React components. The domain knowledge for that task is with my front end engineers. They're the ones that are going to supply that estimate. Task number 3, maybe this is a database requirement. So you need to develop some queries and maybe some indexes on the database or do some migrations on some tables. That task is a database task, and the database engineers are going to provide that estimate. So that's their domain knowledge. That's important that the people with the domain knowledge are actually providing the estimates. So at the end of an estimation process, I end up with this data. And let me say this real quick. I'm presenting visually this data in a table. If you're managing your backlog in Excel, you're doing it wrong. So please use a proper tool, something like Jira or something equivalent like that. So I'm just doing an example here of a table because visually you can kind of see the data. But let's take our data and let's talk about this a little bit more. So one of the questions you might ask is you see these size numbers, 1, 3, 2. That obvious question is, what is the unit for size here? And the two most common approaches are people will size this in what we call points, or relative values. Task 1 is 1 point, task 2 is 3 points. So relatively, task 2 will take 3 times as long as task 1. Another option is some unit of time, let's say days. 1 day for task 1, 3 days for task 2. I like to decouple my estimates from the actual time. So I prefer to use points. And that way, when you're in meetings and you're talking about these times, and somebody who maybe doesn't have as much experience is kind of attending your meeting, maybe that day the CTO shows up and they're in your meeting and they're hearing you say, task 1 is going to take 1 day. Well, they don't really understand the process. 1 day means 1 day of working time, right? So once the engineer gets time to do it 1 day, they may not understand that's a back-end task for a database engineer, but that database engineer has 3 other tasks before them. They don't understand that process, right? How it's all lined up. So I like to decouple those so that there's no misunderstandings about when this project is going to actually get done. And I prefer the units of points. So that's my suggestion. But the truth is, it doesn't really matter. You can use points, you can use days, you can call it kittens. It doesn't matter. What's going to happen is you're going to size a task, say it's 10 points. And then at some point, we're going to compute a velocity. And it's going to be so many points per day. It's 5 points per day. And so when I take 10 points and I divide it by 5 points per day, the unit of points is going to disappear. And I'm going to get days back. So if you want to talk in kittens, 10 kittens and 2 kittens per day, and I end up with 5 days, it doesn't matter. It really doesn't matter. The most important thing is that the team consistently provides these estimates. If I gave the team task 1 today, and the estimate is a size 1, and then I gave that same task in a week, the team should come back with a number 1. That consistency is what is important. And again, we already talked about this, that maturity level, right? We're going through that maturity model and we're at the high performing team and we're able to consistently provide those estimates. That's where we want to be. But let's talk about the impact of maybe adding a new team member or removing a team member. If you add somebody that's new, or maybe you're going to remove somebody that has the domain experience, that's going to impact your estimates. Let's talk about, hey, you just expanded your team, you added a new person. So that person is going to need some coaching on kind of this estimation process, what we just talked about. Like these points are relative. We're doing points and they're relative points. And that task 3 is going to take 3 times as long as task 1. And that's part of the coaching process, right? To just kind of orient them with, our sizing process. The other thing new engineers don't really understand is maybe your whole software development pipeline. What does that look like? Sure, they are probably familiar with pieces of it, like writing code or writing tests, but maybe, again, you're a medical device company and you have some FDA compliance parts in your process, and they don't really understand how to estimate those. They don't have any experience there. So they can borrow experience, and that's part of the coaching, right? So you're letting them borrow your experience, and you're saying, hey, this is going to add a little bit of overhead. So you want to adjust for that factor. Talking about process, if you ever change your process, let's say we're at a company and we're working together as a team and we have a certain process, or we fine-tune it in and our uncertainties and our estimates are really low. And somewhere along the line, the leadership team has had discussions with the FDA, and it turns out that this is really a medical device. So now we have an FDA process that we have to kind of fit into our existing process. So our old process was well defined, but now our new process is going to have some new compliance tasks that are involved. What that means is, a task that maybe I sized yesterday of a size 1 there's some overhead. So maybe that's now really a size 3. So there's really kind of two ways to mitigate this. Is you can go back through and you can update all your sizes and try to adjust for this process. I don't really recommend that. I recommend that you keep your sizes the same. And the second way that this gets mitigated is when you compute your new velocity. And we'll talk about how that velocity is computed in a little bit. But that velocity, instead of being, say, 10 story points per day, it's going to be reduced. It's going to be a number like 8. And you're going to get 8 story points per day. So we'll just let it naturally fall out. So the process of going from a lighter process to a heavier process, when I compute my velocity, that's going to just fall out of there originally. So no need really to go and compute new numbers for your task sizes. Those are already computed. Leave those alone. The team should continue to consistently provide those same numbers, but now our velocity will change. Initially, during that transition from the lighter process to the heavier process, there's gonna be a period where maybe your numbers and your team isn't really, providing as accurate of numbers as what they used to. Don't worry about that. As time passes and you get experience, those uncertainties will reduce again, and you'll get back to the point of, providing super accurate estimates again. The same thing happens when we introduce new technologies. Let's say right now we have a front end that uses kind of the traditional web stack of HTML, CSS, and JavaScript. We're just writing the traditional code for web front ends. So as time has evolved, architecturally, we see a need now to introduce a new technology. We're going to introduce React so that we can componentize that front end. That introduction of that new technology is going to have some impact on our estimates. Again, we've introduced a technology where maybe nobody has experience on the team and they need to be able to ramp up with that experience. And during that ramp up time, uncertainty levels are going to increase because I don't really have experience writing React components yet. And so I need to be able to gain that experience. And as I gain that experience, my estimates will be better and my uncertainties will be lower. Another very common thing is to use kind of a Fibonacci series of numbers, 1, 2, 3, 5, and you can see the rest there. One of the things I want to caution you about is if you start to get numbers that are large again, like if somebody comes in and they size a task at a 20, that probably indicates that task is too big. I mean, imagine these units are in days, and I have a task that sizes 1 day, or I have a task that sizes 20 days. This 20-day task has a lot more uncertainty into it. So the best practice is if you have tasks that are larger than 5, try to break those down. Take that 20 task and maybe break it down into 4 5s if you can. That way, your estimates are going to be a little more accurate. We finally have got to the point where we've got feature 1 all sized up, and we have a total of 18. We're going to go with points. So 18 points. So the next thing is I have to figure out what my team velocity is. And what I've shown here is like the typical Scrum process. You have this backlog, and then you have sprint planning that takes some stuff from the backlog and puts it in the sprint backlog, and then you have a sprint. And this day it's picturing 30 days. And so for 30 days, your team burns down this sprint backlog and you end up with an working software in the end. So let's assume that we're kind of running that process, and I'm going to start to track my data. This is one of the critical things that the team needs to do, and maybe there's a specific role in the team. Maybe it's the team leader that does this or the project manager that does this, but somebody needs to have this data, and they need to track this in order for us to accurately provide any kind of estimates at all, or for us to be able to accurately plan a larger project. We need this data. For sprint number 1, in this particular example, I'm using a 10-day or 2-week sprint. So it's a 2-week sprint. I got 10 working days instead of the 30-day sprint. So that 10 working days, I have 5 people on my team. So if you compute the total, there are 50 team member days on there. And so at the end of sprint 1, I had 60 points completed. Now it doesn't matter what you put into sprint 1. So maybe I took in the beginning 70 points in my sprint backlog, but I was only able to complete 60. The remaining 10, they get bumped to the next sprint. That's just the reality of what has to happen. They're going to get bumped to the next sprint. But in my data, I need to track only what I completed. So the team completed 60 points. So now I can take 60 divided by 50, and I get 1.2, and the units on this are 1.2 points, because that's the unit we decided that we're going with, per day per person. So if you look at just one person on my team, on average, they're going to complete 1.2 points per day. That's what that number means. Now, because this is sprint 1 again, highest uncertainty. We just started off as a team. But if we fast forward, and let's say we've got to the point where we've done 54 sprints, I haven't changed the number of days on my sprint, so it's always 10 all the way down the line. You can see a little bit of fluctuation on the total team days. Remember, I got 5 people on my team. But here on sprint 50, I had 2 people go on vacation, right? One for 1 week and then another for another week. So I had a total of 10 days that I couldn't count as team member days. Those were accounted for in my planning. So 40, I only have 40. And for each sprint, I've tracked the total number of points that the team has completed. And then over here, I computed the velocity. So this column is, again, it's the total points divided by total team member days. And I can compute the velocity, which again is points per day per person. Now, the thing that has changed is because my team has been working this process for a while. I haven't changed process. I haven't introduced new technologies. We're getting pretty consistent, right? So the numbers have a lot less uncertainty. They really reduce the uncertainty in the numbers they're providing. And so if you look at these numbers, they're pretty close, right? So they're not a lot of variation in here. And if you take a mathematical concept like standard deviation and you compute it, which we'll show in a second, you would get a pretty low standard deviation. So one strategy then is I always use my most recent number as my velocity. So when I want to compute how long things going to take, I grab the most recent one. That's what the team's running at. Probably a little bit better strategy is to take an average over, say, like the last 5 sprints. So you take an average, and that way you can kind of even reduce that uncertainty a little bit more, because the sprint to sprint variation may be due to some things that were unforeseen, like maybe somewhere here where we only got 65 points. Maybe during that sprint there was a draw on your team from the ops team because there was some troubleshooting or some customer support issues that you had to push team members to that was unexpected. So those sprint to sprint variations, we can kind of normalize those out a little bit and get the average. So now I've got my data and I can make data informed decisions. So I got my working velocity. The average working velocity is 1.38 points per person per day. The deviation, standard deviation, we computed this, and you can see that number. It's pretty small. So, and I can also use my average working velocity to back into kind of my sprint size. What's the payload that my sprint can handle? And I can take the 1.38 points per person per day, multiply it by the number of days in my sprint, and multiply it by the number of devs I have, and I get the number 69. So when I plan my next sprint, I should be planning to fill this sprint with 69 points. That's what my team is on average doing. So somewhere around 69, maybe it's a little more, maybe it's a little less, but that's the number I'm heading towards, is 69 at this day. Now, if I fast forward another 50 days, maybe my velocity's changed and my sprint payloads are different. So I have to always kind of compute these numbers, and I'm driving my decisions towards those numbers. Okay, so we got our velocity. It's time to get onto the business of what the question was, is how much time is this going to take? We're back to one of those story problems. And I know my total size is 18 points. My working velocity, I just computed it, was 1.38 points per day. I got this formula, so change for time, and I can compute the estimated time. It's 13 person days. If you're not used to these units, then you might be asking, well, what does that mean? And maybe you have some kind of questions or some considerations. I mean, does it mean that one person can complete this whole feature in 13 days? And that answer is maybe, right? So it really depends. If you think about your stack, your technology stack, maybe you've got React on the front end, Node on the back end, and maybe there's like a relational database here for storage. And so you got 3 teams. You got a front end team, you got a back end team, and you got a database team. Now, domain knowledge on these tasks, they need to go to the proper team. And so can one person complete this in 13 days? If the feature spans all of those teams, probably not. You probably want to take those tasks and assign those to individual people, so you're not really assigning one person. Another thing that you might hear someone who maybe doesn't have the experience is they might say, okay, that's great. So I'm going to give you 13 people. You can finish in one day, right? And again, the answer is probably not, because that's going to be like too many cooks in the kitchen situation. And if you remember, this particular feature, there's only 5 tasks in there, right? 13 people, how are you going to divide them into 5 tasks? Maybe it makes sense to do 5 devs, but it probably makes more sense to queue these tasks with the individual teams, the front end, the server team, the data server team. And so the tasks go with the teams, and then they can burn down their queues from there. So no, the answer is 13 people. I'm not going to be able to finish it in, one day. Just like if I were to throw 100 people in at it, it's not going to get finished in sub 1 day, right? So that's just not the reality of the situation. Another thing that you might want to ask here is this sprint full? And the answer is no. This feature has 18 points, right? Remember, my sprint size was 69 points, so I can top this sprint off with other features. I want to fill this sprint so my team isn't just working on this feature, but they have other features in this sprint also, and that's important for a lot of reasons. Okay, so we have some considerations we talked about. It's important to also ask the question, what can go wrong? I provided this estimate, 13 person days. Let's say I'm going to assign 2 people to this. And so it's mostly front end and back end tasks. So I got a React developer and I got a Node developer, and I'm going to assign them all the tasks, divide it say equally, and it's going to be 6.5 days. What can go wrong? And so there's a number of things that can happen. One of the biggest things are dependencies. Say task 2, I'm a front end developer, but I'm kind of relying on some API that the back end developer is creating. So task 2 maybe can't get started till task 1 is completed. And so there's these dependencies. And so we need to be able to kind of mitigate dependencies. There are some techniques. For example, as the backend developer, I can provide kind of the interface for the API. Say, hey, this is what the API is going to look like. I don't have it working yet, all right, but I'm just going to stub in an interface. It's going to return some dummy data, and you can carry on and do your work. So I've unblocked task 2 because I've kind of provided that interface for them to develop against. So there are techniques like that, but you want to understand these dependencies. You want to line them up. And that way we're making sense of where our potential areas where we might become blocked are. And a related thing is external dependencies. Maybe task 3 doesn't depend on anybody on our team, but it's dependent upon something that happens in another team that we don't really have control over. They're not in our department, but we still are dependent upon their outputs and what they're doing. A typical example is task 3 is going to require a server that IT has to stand up. And again, as a developer of task 3, I probably would go ahead and maybe get a Docker image of that server running on my local machine so I can carry on and do my development against that local server. But really, until the real IT server is running, I can't really test my code against the real IT server. So there may be some issues still with the integration, security issues, networking issues, but those things might happen. But I can still have my local Docker version running, and that allows me to kind of do most of my development, but I still may have some issues when the real server comes online. Other important thing is to introduce this dependency into your sprint, whether it's a ticket that has 0 points because your team's really not doing it, but at least you have a ticket and you can see the progress of that ticket. But IT is not going to come in and log into Jira and manage that ticket. The developer for task 3 is going to manage that ticket as part of their process, and they're going to move that IT ticket from the different swim lanes and provide visibility to the team. And that way, as a manager, if I see that my team member, one of my developers is getting blocked, I can escalate this up to my leadership, and then they can talk to their peers, and they can escalate that back down to the people actually doing the work, and maybe see if they can get it done a little faster. Another common thing that can go wrong is a developer is just not able to put the time in. I mean, we plan these sprints. I got 5 developers. I'm planning for 50 hours, over my 2-week sprint, and the situation has come up where maybe I had somebody out sick. That's something I can't really plan. But maybe there's also things that kind of erode my 50 hours. And so maybe, like, for example, my team regularly has to provide operational support. We know the production environment the best, so the team provides operational support. And so one of the things that I can do when I'm trying to plan these sprints is I can pull out those operational support tickets. I can allocate those. I know I have a team of 5. That's going to give me 50 team days. And maybe I already know that of those 50 days, 10 of them are always going to be spent supporting ops. So I really can take my sprint planning and maybe only use 40 days, but I'm going to allocate the 10 to ops. So that's really kind of one of the best practices, try to anticipate how much of the 50 really going to be used for ops. I can pull that off, and then I can do the planning. And instead of trying to anticipate all the answers to what can go wrong, the best practice is every single day the team meets and every developer on the team is forward looking, what they're going to do today, tomorrow, and maybe the next week. And they're trying to anticipate any dependencies where maybe they should raise a flag. As a developer, a front-end developer, I need that API. As maybe an API developer, hey, I need that data server set up by the IT team. Those are the things that we should anticipate as developers. In our daily huddle, we should raise those flags. So those flags that get raised are really risks to the project. And so those need to be tracked. Maybe you have a dedicated person on the team, like a project manager, to do it, or maybe that's the team lead. But somebody needs to track all the risks. And then we also, as a team, we need to figure out what the best way to mitigate those risks are before they have any impact to our schedule. All right, so we've come a long way. We now know our velocity, we know the estimate for feature number 1, and we can do the same thing for feature 2, 3, 4, whatever number of features we have. Now what we have is kind of a bigger picture. We have all these features, and we've sized them up, and again, not at the feature level, but we broke them down to tasks and subtasks if we needed to. We rolled those back up, and we got the number. 18 was our number for feature 1. We did the same thing for feature 2, and so on. Over here, I also know, because I'm tracking my data, and I know that I have 5 devs and 10 days in every sprint. So I know every sprint is about 69 points. That's what I'm planning against. And that's based upon that average velocity that the team currently has. And I'm also counting for anything like holidays or vacations. So I'm adjusting my total of, say, 50 days. If I know someone's going to be out for a week, it's not 50 days, it's 45 days. And so I'm adjusting all of that as I go, very dynamic. And then I'm also taking that other best practice is if I know that my team is supporting other teams' ops, for example, and I also know that the average number of time, because I'm tracking the data, is going to be 10 points that is going to come out of my work time, I can subtract that out. Maybe in this particular case, I start off with 69 points. I don't have any holidays or vacations, so I still have 69 total points that I can put into a sprint. But on average, 10 of them are going to be dedicated to ops. So I'm going to have 59 points that I can work with during the sprint. And so for every sprint, I start to fill up that bucket. I have a bucket size at 59. 18 fits in for sure. 18 and 32, I'm at 50. I can still get 9 more points. So I pull 9 points if I can from feature number 3. Now, if I can't get exactly 9 points because maybe the tasks aren't that granular and I can't add them up, maybe I'll only pull 5. Or 4. I'm just doing the ideal case. I'm pulling exactly the 9 that I need. And I got sprint 1 full. And I do the same thing for sprint 2. This task has 39 more points. So I take the 39 of it, and then I can fit 20 more from this feature. So now I have sprint 2 defined. What is sprint 2? And I carry on down the road. So I have sprint 3, I have sprint 4, and sprint 5. Everything's planned out at this point in time. This is what things look like. And that's a very important part is when I create these plans, these are not static. This is the plan as it is today. And yeah, I would love to promise that, hey, this is exactly what it's going to be like. And we've done our best to reduce the uncertainties so that I kind of know my numbers are as accurate as they can be. But there are still things that may happen. And again, one of our uncertainty principles was, things that are out here on sprint 5, that estimate that I'm going to get that done in sprint 5, that has more uncertainty than this estimate that I'm going to get this done in sprint 1. So I need to be able to relay that. So it is important that when we communicate and share this plan with other people, that we're also communicating the uncertainty levels. And, as an example, feature 1 will be completed in 2 weeks. That has a pretty low uncertainty level because that's the current sprint. We're working on that right now. And it's in progress. The team is going. A lot of risk has already been mitigated. That has a very low uncertainty. And in this case, we're just saying everything between 1 and 2 months. If I provide that estimate, that has low uncertainty. And then anything 2 to 4 months out, maybe I say, hey, sprint or features 1 through 8 will be completed in 10 weeks. 1 through 8 are here. I add them up. I got 5 sprints, 5 times 2, that's 10. That estimate is that's more uncertain than the original one of, hey, feature 1 will be completed. And I'm calling it medium uncertainty. It doesn't mean it's bad, but there is more uncertainty with that statement. And then the one that has the highest uncertainty is anything that's greater than 4 months. If I'm saying to you, hey, features 1 through 20 are going to be completed in 40 weeks, that statement has the highest level of uncertainty that I can say. So what every team member needs to do, whether you're a software developer or you're talking to your manager or your manager talking to your director or your director talking to the CTO, they need to be able to provide these estimates, but also they need to be able to relay the uncertainty with those estimates. Estimates always need to be communicated with an uncertainty level. And just to reiterate, I'm using the term as high, but I'm not saying that this is way off, right? 40 weeks, maybe it's not going to be done in 40 weeks. Maybe it's plus or minus 2 weeks, plus or minus a sprint there. That's what we're talking about at this level is at 40 weeks out, maybe I'm plus or minus a sprint or 2. And we talked about the causes for maybe why things might change and upset our estimates. But we didn't really address one cause that's pretty common. As a software development team, we've done our very best to reduce uncertainty, kind of using our 4 principles. And we're communicating, this is going to be done in 10 weeks with this level of uncertainty. So we're doing the best practices that we can do. One of the uncertainties that the software development team doesn't really have control over that we need to also address and talk about are there's uncertainty in these features. And this happens all the time. So as you start to develop these features and you're pushing them through your pipeline, and they're going through user acceptance testing, right? So now these users are accepting feature 1 and they're accepting feature 2 and the feature 3. And as they start to see these features that you've developed, they're really inspired. They didn't know that you were going to make this so great. And now they're thinking, oh, okay, well, we can enhance feature 1 or change feature 4. So these are the kinds of things that will happen to your backlog that will impact the uncertainties that the software development team has done. And that needs to be communicated correctly also. If these features change, then my estimates get to change also. You can't change what feature 4 looks like and expect the team to get it done in the same amount of time. That's just reasonable and that makes sense. But a lot of the times, that's not really fully expressed. And we need to stay on top of that and understand that any changes to our backlog will also impact our estimates. And finally, at the end of every single sprint, we have new data. All of these numbers should get adjusted. And adjusting your numbers, maybe you don't have to adjust them every sprint, but when they get adjusted, those changes need to be communicated. If estimates change, the nice thing about this process is, you have all the data to have that communication and discuss this, right? Providing visibility into why feature 5 is taking longer, that's no problem, because you can say, well, the requirements for feature 5 have changed, right? So it's going to take longer. Or maybe it's you're waiting for IT to stand up some server, but they're waiting to provision the server, but because they don't have the hardware. So they had to purchase the hardware, but the hardware's not coming in for a month. So those kinds of things can be roadblocks, but at least you have all that information and you can communicate then what we're doing to mitigate those risks. That's a very important process. Is every single sprint, numbers change, and we need to be able to communicate why those things changed. Let's just kind of conclude with what we've learned. Providing estimates for software can be scary, but there's some fundamentals that we can apply to make this go a little bit easier. So first of all, accurate measurements, they require domain knowledge. I shouldn't have my React developers trying to provide an estimate for how long it's going to take to write some database scripts, unless they have that domain knowledge. And if there's something that you're introducing that maybe you have no domain knowledge on, so maybe your team, one of the features that's coming up is you're introducing some technology that your team's not familiar with. So maybe you want to have an LLM, so a large language model chatbot that's going to be embedded into your team. And so that LLM technology is something new. And so if the team were going to try to provide estimates on integrating that chatbot, that might require them to gain some domain knowledge before they did that. So we might be planning 3 or 4 sprints ahead of time and tasking some team members to learn about that new technology. So then when they actually have to size that task, those sizes can be a little bit more accurate. We talked about a maturity model for teams, and that mature teams can do 2 things. They can provide consistent sizing, and they also execute at a consistent velocity. And velocity, again, that's something that we should be measuring. As a project manager or team leader, I'm measuring my team's velocity so that I can use it to kind of compute estimates. I need to be able to know what that number is. Then knowing what that velocity is, I can use that number to back into what my average sprint payload size is. So I can then plan out all my sprints. So sprints should also include kind of time or points for not working on features. Maybe I'm doing ops support. If that's a normal thing that your team has to do is ops support, have a task in there for ops support and go ahead and pull that capacity out of your total so that you can plan appropriately. So dependencies can be a real killer to the accuracy of your estimates. The worst case scenario is you may have to shelve or queue a task while you wait for its dependencies to be completed. And maybe those dependencies aren't on your team, they're external dependencies. But one of the hardest parts about having a predictable pipeline is actually minimizing all the uncertainty. We've done that really well as a team, and proactively mitigating kind of all of the risks associated with any tasks that we might do before they impact the schedule. So that's it. We've covered the fundamentals of providing good software estimates, but more importantly, we've established kind of a framework where our team that's composed of not just software devs who kind of have the technical knowledge to kind of do the estimates, but also it's composed of managers and product owners and maybe sponsors or maybe clients themselves. But we have this common language now that we can use to describe these estimates. So it's not just, it is going to be done in 6 months, but now everybody can understand this is 6 months, but the uncertainty at the 6-month level is higher than if I told you this was going to be done in 1 month. Because those tasks in 1 month, I've reduced and I've mitigated the risks. Those numbers are a lot more accurate. They have a lot less uncertainty. There's a few more topics I like to cover in software development best practices. So if you want to see those, Hit that like button and subscribe below.